Everyone, this is Dr. Vivek Laha, and today we are going to discuss production problem and their mathematical formulations. So let us start with some different types of decision making problems. So suppose it can be a production or manufacturing problem, it can be a marketing problem, it can be problems from finance, it can be agriculture problems, it can be transportation problems, it can be assignment problems, and so on. So let us start with a simple production problem. A manufacturing company is engaged in producing three types of products A, B, and C. The production department produces each day components sufficient to make 50 units of A, 25 units of B, and 30 units of C. In the assembly department, only 100 man-hours are available daily. Now, this is the data associated with the production problem. The profit contribution per unit of the product in rupees. For A it is 12, for B it is 20, and for C it is 45. Whereas the assembly time per product in hours is 0.8, 1.7, and 2.5 for A, B, and C respectively. Now the company has a daily order commitment for at least 20 units of products A and a total of 50 units of products B and C. The question is how many units of the products A, B, and C should be produced to maximize the total profit of the manufacturing company. The step 1, which is to identify the decision variable. First of all, we have to identify the decision variables. And the part of the question that how many units of products A, B, and C should be produced to maximize the total profit of the manufacturing company. So this part, that how many units of the products A, B, and C should be produced. So, as per this part, we assume that the number of units produced for A is x1, for B it is x2, and for C it is x3. So, these are the unknown variables x1, x2, x3, and we call them as decision variables. So, now we have to find out these decision variables. The other part of the question is the production department produces each day components sufficient to make 50 units of A, 25 units of B, and 30 units of C. So this is 50 units of A, 25 units of B, and 30 units of C. So now this is uh, we have to identify the constant in this part of the question, and that is production constant. So if we consider that the number of units, so units of A are less than or equal to 50, units of B are less than or equal to 25, and units of C are less than or equal to 30. So this x1 should be less than equal to 50, x2 should be less than equal to 25, and x3 should be less than equal to 30. Now, in the assembly department, only 100 man hours are available. So, this 100 man hours are something which is the constant, and that is a time constant. So, the third constant is time constant, and we have to mathematically formulate this constant. So, this part, this production, see A, B, and C assembly time per unit in hours. For A it is given, so this part is given in the question, and this part, this is x1, x2, and x3. We have assumed that the number of units of x1 of A is x1, for B it is x2, and for C it is x3. So the time will be 0.8 x1, 1.7 x2, and 2.5 x3. So the total time in hours will be 0.8 x1, 1.7 x2, and 12.5 x3, but it cannot be more than 100 units. So this is the constant. So we have associated this constant with this mathematical form of this constant. Now The company has a daily order commitment for at least 20 units of product A and a total of 50 units of product B. So 20 units of product A and a total of 50 units of product B and C put together. So again, this is a constant, and this is, we call it a commitment constant. And as per the conditions given, the number of A should be greater than equal to 20, and for B and C together should be equal to 50. Now, uh, the number of constants cannot be negative, neither it can be negative, not it can be in, it should be fractional, so it should be integral. So x1 plus x2 and x3 should be greater than equal to 0 and are integers. So step 3 is to identify the objective functions, and it is to maximize the total profit. So now this part, the profit is given here, and we have assumed this. So if we multiply this with 12x1, so it will be 12x1, it will be 20x2, and it will be 45x3. So total profit is 12x1, 20x2, and we assume it, and we have to maximize this profit. So if you combine all the functions together, so it will give you the maximization of z. So it is the mathematical formulation of the production problem, and since the objective function and all the constants are linear, it is a linear programming problem, whereas since only integral values are permissible, it is also an integer programming problem. So what are the conclusions? So the production problem, we identified the decision variables, we identified the constraints, we identified the objective function, and then we formulated all these things, and we formulated a production program, integer linear programming problem. So now the question is how to solve a linear programming problem. It may be solved by graphical methods, simplex methods, dual simplex method, Moore's algorithm, branch and Brown method, Hungarian method, and so on. So we will discuss about all these methods in our upcoming videos. Thank you for watching, and thank you for watching.